In this problem, we're going to use the chain rule, because if you look at this problem 3.2.3, we want to find the derivative of f of g of x if we have f of x equals square root of x and g of x equals x squared plus 10. Now up above you can see I've written the formula. So this is the formula that we like to use if our functions were given to us as two separate functions. So the derivative of f of g of x, you don't actually have to do the full composition. You can skip straight ahead to where the answer will be. It'll be the derivative of f evaluated at g of x times g prime of x. So what you do is you come to this problem. We have a problem written out, and you say, okay, well that's f of x. Let's find f prime of x exactly like we normally would. So the derivative of the square root of x, that's your like x to the 1/2. So it would be 1/2 x to the negative 1/2, or 1 over 2 square roots of x. And g prime of x would just be derivative of x squared plus 10 is 2x. So again, we take those derivatives like normal. But then what you do is you need to find this f prime evaluated at g of x part. So f prime evaluated at g of x means you're going to take this g of x and plug it into f prime, wherever you see x. So it's going to be 1 over 2 square roots and take your x squared plus 10. So now we found all the pieces that we need. Let's go ahead and plug it into our formula. So the derivative of f of g of x is going to be f prime evaluated at g of x. We found that. That's 1 over 2 square roots of x squared plus 10 times, now it says times it by g prime of x, which is 2x. Let's see. So in this case, our 2's are going to cancel, so we'll have x over the square root of x squared plus 10.